Okay, we're back to the simultaneous pressure tracing. This will be 13B, simultaneous. Where we were was to look at the left ventricle, okay? We had already established that this right here is isovolumetric, that sliver there. This sliver here, ejection, contraction, relaxation. We started here with the left ventricle. The catheter is placed in the left ventricle, getting some pressure recordings. We said right here, the left ventricle is doing an isovolumetric contraction, a rapid rise in pressure, like squeezing on a closed water bottle. We said here that you now have opened the outlet valve. See, to start it, you close the inlet valve. If this is the left side, then you close the mitral valve, bicuspid valve. Then the pressure started rising because you had a closed valve and you're squeezing down. Then you open the aortic valve, and right here, the aortic pressure and the left ventricular pressure are the same because the door is open. Then you start relaxing. You start relaxing and start again. So we were back here. I was saying that right here, the ventricles are filling. Now, the reason you don't see any significant pressure increase is because the ventricles are filling, but they're relaxing as they fill. Okay? Relaxing as they fill. Then, so this right here would have been rapid ventricular filling and diastasis. But here is where you squeeze blood into the ventricles, atrial systole. The ventricles cannot relax as fast as you can squeeze because you're squeezing the pressure. So that's why you see this pressure rise. So back here would be rapid ventricular filling, diastasis, slow ventricular filling, isovolumetric contraction in the ventricles, ejection, contraction, relaxation, and you're starting again. All right. Now what we wish to do is to push the catheter in further and now get a recording from the atria. Okay, so that would be this line. Okay, the catheter's in the atria. The atria has three waves that I'm just going to mention. An A wave, a C wave, and a V. Now I'm going to come here. It has what we call a A wave, a C wave, and a V. A A wave, let me go back here, a A wave, a C wave, and a V. Okay, this is with the catheter in the atrium. So here's the catheter here. It would be in the left atrium because it's the left sided heart cath. All right. The A wave corresponds to atrial systole, as you can see. The C wave corresponds to ventricular systole. You say, well, what is that? Okay, here's what's happening. Assume that you've just squeezed blood into the ventricles. The ventricle now starts to close. When the ventricle closes, it pushes a back pressure up on the valve, which then shoots pressure back into the atrium. Let me say it again. When the ventricle starts right here with this isovolumetric contraction, it pushes the valve. The valve then, any blood that was attempting to come in from the atrium into the ventricle gets it slapped back into the atrial's face. Therefore, there's a pressure from that backflash of blood. So that's the A wave, the C, and here's the V, which is basically atrial filling. Right here, you're doing atrial filling. And then you're back again starting. So atrial systole, ventricular systole due to a flash of blood, and atrial filling. Now, so that shows the simultaneous. Now let's prove this. Let's look here at the ventricular volumes. Now let's pay attention as we look at the ventricular volumes. Let's look at this ventricular graph right here, the ventricular curve. Okay. Right here, we see that the ventricles are filling. right here is the fullest the ventricle will be. See, that's EDV, earlier discussion, end diastolic volume. That's the fullest the ventricle would be right before you do ejection contraction. See, that's right at the end of isovolumetric contraction, because you can't put anything in there at that time. Okay, now, ejection contraction occurs. What did we say? We said this here was ejection contraction. What happens during ejection contraction? You dump blood out of the ventricle. See, you're now going down. Volume going down. Then we finished right there. That's the emptiest the ventricle will be. Now remember from earlier, and when we did the cardiac output, the stroke volume is the difference between the fullest, which is EDV, and the emptiest, which is ESV, because that's how much you put out. So what this does, looking at the volume, is to confirm what we said is happening in the ventricles. All right. We go to the next portion here. Now we're into heart sounds. Now let's think about heart sounds. Heart sounds occur when valves close. Heart sounds occur when valves close. Okay? We said there were two heart sounds, an S1 and an S2. The S1 consists of the mitral and the tricuspid, the S2, the aortic and pulmonic. However, in this situation, we're only looking at the left side of the heart. We're only looking at the left side of the heart. So S1 then, since would only be a mitral look. S2 would be an aortic, because over here would have been the right side, and we're only looking at the left heart in this drawing. So, S1, closure of the mitral valve. When would closure of the mitral valve occur? Let's think about that. That is when you contract and close that valve, right? That would be at the initiation of isovolumetric contraction. Right here. Let's go up and see if we see it. Uh-oh, there it is. S1, right at this point right here. S1, right at that point right there. Because what that's doing is, that is the beginning of isovolumetric contraction, which closes the bicuspid, i.e. mitral valve. Right? Let's go further. When does S2 occur? Closure of the aortic. Okay. When would closure of the aortic occur? Right here. Remember, that's that dicrotic notch. That's when that valve closes. Because that's when the left ventricular pressure and the aortic change. Valve is closed. Oh, let's go up. S2. Right there. So we've confirmed now the first heart sound, S1, and the second heart sound corresponding to what we said occurs during the cardiac cycle. Okay? Now, the last part of this is to do the EKG. The last part is the EKG. Okay. We said the P wave is atrial depolarization. The P wave is atrial depolarization. We said the P wave would send the signal to the atria to cause atrial contraction, which would occur during atrial asystole. So if we come down some, we can see here's the P wave, and shortly while the P wave is going on, you get atrial systole, showing that the P wave, atrial depolarization, which is a charge activity, would lead to the mechanical activity of this. We said the QRS was involved with the ventricles. Well, the QRS is starting here because this is ventricular action, ventricular systole, isovolumetric, ejection, contraction, relaxation. So we can see that QRS is starting, and that excitation is leading to this particular action here. Over here's the T wave, ventricular repose. That's when the ventricle starts to relax. Look, this is contraction, relaxation. Contraction, relaxation. So you can see that this EKG is corresponding directly to what we said was occurring in this. So that shows you simultaneous, studied on your own, all the things that are happening at the same time, quote, during one cardiac cycle. All right? Thank you there.